let's think about the fundamental theorem of calculus physically. Well, let's define a function v by the rule that v of t is my velocity at time t. Now, physically, what does the accumulation function of velocity mean? Well, that accumulation function, remember, is, say, the integral from 0 to b of v of t dt. And this is really the distance that I've traveled from time 0 to time b. This also makes sense when we think back to Riemann sums. Well, what would the Riemann sum say? If I think about how far I traveled over a short time period, say between time 0 and time h for some small number h, right? How far did I travel during that time period? Well, I traveled for that small time period h, and I was traveling at a speed of, velocity at time 0, say, is a good approximation. I imagine my velocity didn't change very much during this time period. So that's a pretty good approximation for how much I traveled during the first h moments of my journey. What about between time h and time 2h, right? How far did I travel there? Well, the time that elapsed was h units of time, and how fast was I going? Well, I could use v of h, my velocity at time h, as a good approximation for my velocity over that time period, right? My velocity is not necessarily constant, but this is standing in for a reasonable approximation if my velocity is not changing too rapidly. All right, so this is how far I traveled, right? Time times velocity is distance. All right, now how far did I travel between, say, time 2h and time 3h? Well, again, how long was I traveling for? h units of time. And how fast was I going? v2h is a reasonable approximation for my velocity during that time period. And of course, this keeps on going, right? But what do I get if I add all of these things up, right? What I'm getting is a Riemann sum. And if I keep on adding these things up until I get, all the way to b, right, what I'm writing down is the approximation for this integral, a particular Riemann sum, which approximates this integral. And in the limit, as h goes to 0, that Riemann sum will compute this integral. So summarizing that, the accumulation function of velocity is displacement. And what's the derivative of displacement? It's velocity, right? The derivative of my accumulation function, in the specific case where the accumulation function is the accumulation function for velocity, right? The derivative of that accumulation function is the thing that I'm integrating, velocity. That's the fundamental theorem of calculus. Or in symbols, the accumulation function, which is calculated by displacement, is the integral from 0 to b of my velocity. And what I'm asking is, how is that changing, right? If that's my displacement when I travel from time 0 to time b, right, what is the derivative with respect to the time that I've been traveling? The derivative of displacement is velocity. So physically, differentiating the accumulation function of velocity is to differentiate displacement. It's to ask for the rate of change in my position, which is velocity, which is the integrand. It's the fundamental theorem of calculus, just wrapped up in physical clothing.